you. Thank you so much.
With that thought in mind, we want to bring in Manish Gupta. He is the CMO of Liaison, which is a data platform company. And as Vic was mentioning, the data lake, this is the company that translates what data lake is supposed to be into real tools and bytes. Manish has many years of experience. He's been a serial entrepreneur. He's worked at big companies like Apple, National Semi, and with lots of experience, he's going to talk to a very distinguished speaker we have from Clorox, and ask Manish to introduce him in detail. But Clorox, again, is one of those old school companies that you may not understand. Many of you use it, but you may not understand that it's leveraging data to literally transform how business gets done. So with that, I would request Manish to come on stage.
So welcome, everyone. I'm Manish Gupta, and my partner here on stage is Yigal. Let me do a quick introduction for Dr. Gur. He holds a PhD from Israel Institute of Technology and has several publications and patents to his name. He's been with Clorox for several years and has a long history of putting together new algorithms. At Clorox, he is part of their enterprise data architecture team and is leading the effort to build the next generation data platform for advanced analytics. So please give a round of applause to Dr. Gur.
Thank you very much. I was kind of trying to explain that I was doing data science when nobody knew that this is data science. Okay, we just happened to be in the right place and being lazy, trying to solve a very difficult problem in physical chemistry. So it was targeted approach toward experimentation, toward everything, all the dimensions what it had. So that's where I'm from.
Great. I think you've heard a couple of sessions this morning, and no one's going to argue that there is a lot of data that traverses our life. And for the enterprises, a lot of data traverses within the enterprise and the ecosystem within which the enterprise works and lives. What we'll talk about today is what enables insights, because the data is great, but if you can't get insights from the data, it's not of much value. And particularly, if you're trying to get insights with dirty data, it's going to be garbage in, garbage out. So it's very important that we don't get hung up on the appeal of sort of the analytics, business intelligence, the fantastic algorithms that Mr. Gur and others put together. There is more to it than that. And so we'll talk about that stack, and we'll talk about what does it take to pull the data in, what does it take to manage the data, and certainly the power of the analytics. And Dr. Gur is going to talk about that in detail. So we've got a couple of pieces here I just wanted to highlight. The conversation is in the construct of, can we just put that slide up, please? Yeah, so the conversation is, how does a system take in the data? How do you harmonize the data? How do you manage the data? And then how do you apply analytics to get the insights from the data? A given enterprise today is seeing the data explode from a multitude of sources, whether it is the social environment, whether it is the sensors that might be in the manufacturing plant or in the retail chain at the stores and other places, or it might be from mobile devices that now everybody is bringing in as an employee, customer, partner, whatever you might be. And you have to treat that data in the context of the systems of record that you have. This is where your data resides. This is your data warehouse. This is where an Oracle SAP ERP system might be managing it. And on the other hand, you have to deal with your partners, which could be suppliers, customers, and other channels perhaps. And that's the customer engagement side. That could be your CRM, Salesforce.com, and others. And within those confines, how do you take the data in, and how do you? And so the first piece is integration. And the integration becomes very complex. It becomes very complex when you're talking about not just a lot of data, but a wide variety of data. Not just structured data that comes in tables and can be set easily up, but unstructured data that tends to change with every minute that comes in. It's not just coming from a particular type of devices, so you have a standard interface that you define, but it's coming from a variety of interfaces. It's coming from a variety of messaging protocols. And so how do you deal with all of that? Taking the data in, transforming the data, and then the next step is what is that magnitude of data that you have now ingested, what do you do with it? It's the harmonization of the data so you can start to make some sense from it. It is perhaps you persist the data, or perhaps you simply passing the data on and perhaps just applying some metadata to it, so now the data can become a bit more meaningful to the next step of the process. And that is the analytics step. And just to make this even simpler and clearer, I wanted to set the stage for our conversation today with a very, very simple example, an example that, regardless of what industry you might yourself be in, whether it's in retail, pharmaceutical, and healthcare environment, whatever it might be, it's a typical marketing manager or a CMO, someone in my position, has to make decisions on spending the dollars of the company. And the intent of that expenditure is so that you can attract greater customers, you can improve the demand, enhance your demand generation capabilities, enhance the brand equity, and so on. But I can't make those choices, and any CMO in a company can't make those choices if they're not able to get insights on the effectiveness of the investment that's going on in the various campaigns, whether it's advertisements, whether it is public relations or others, because we now have to tap into many, many channels. And the issue is, how do you compare the effectiveness and the results from any given channel versus the next one? If you have the data available to you in real time, if you have the data available to you, that's data that you can actually trust, and insights, you can make those judgments. So this simple diagram is trying to kind of showcase the fact that you have a company that's getting analytics of its various campaigns from multiple threads. In this case, it's just for Google Analytics, Facebook, Atlas, and some custom stuff. Those have to be ingested in, then harmonized and perhaps persisted, and then you can take it to a Tableau, or you can take it and apply analytics algorithms to it and expose and show the visualization on a burst, essay, or whatever the toolkit might be. But that sequence of events is a common thread across every industry that you can think of. And it's very important that the integration, management analytics, is thought of as a comprehensive data stack in order to go from the magnitude of the data that you have, the variety and the velocity, to the insights that your business really desires. And that comprehensive data stack is what this conversation is about. I encourage you to send me questions here and certainly interact. But let me pass this on to Dr. Gur to talk about some of the things he is doing on the advanced analytics front.
Well, the picture, what you see in general, it's like an overview trying to encode these mysterious words, what is systems of record. Systems of records existed in business for a very, very long time, practically as long as business existed. And maybe we can trace it yet to very old handwritten things that people discover in Greece, in Israel, and so on, okay? Because what do you think was first discovered? Receipts of sales. And that became quite important. If you cannot control the sales, what you have, you kind of kill your own tree what you are sitting on, because it is a blood life of any corporation is how corporation make money, is making sales. So at least you need to see it, and you remember old times when you had this nice ledger books, in what you paid, what you got, and you can make sense of it. This was the first systems of record. We, of course, started this company a long time ago, about 100 years ago. There was no computer science then. There was no computers either. But principle of sales did exist. And in our museum, you can actually see this first ledgers under the glass now, okay, that, look, guys, even then there were systems of records, right? But guess what happened next? After running months, 2 months, 3 months of this sales operations, you are starting to think, am I doing okay or not? So sooner or later, you have to aggregate all your sales and get up with some numbers that you can compare with previous number, right? So this aggregation became very powerful. And of course, people did it in all times. If you remember yet, pictures, maybe, I don't know, all historical documents was arithmometers, people cranking numbers, getting up, doing aggregation, because aggregation was the simplest implementation, was just adding numbers together. Now, today we do approximately the same things, but we realized very fast, oh my gosh, with penetration of computers into supporting of business, in supporting of these things, we can actually optimize a little bit the process of aggregation of data. We don't need to retype all these things. We can just feed our system of record data, our sales, for example, and get aggregated. This is how the first concept of warehouse came from. Why in the world it is warehouse? Because to get results every time, I need to create aggregation of multi-million records. And actually, the first schema of data warehouse was suggested as attempt to speed up the process of aggregation so that I can address things only what I need to address, I mean facts, and I can throw away all non-interesting things because I looked to the facts through the lens of my dimensions. And that was the proliferation of warehouses. So on this picture, you can see warehouses presented like this little process called aggregation. Now, very soon people discovered aggregation is great. It helps us to see what had happened in the past. It is like driving a car, having closed front window, but looking only in the rear view mirror. And yeah, you can see perfectly fine. Look at nice mirrors, what you have. You can see everything. Does it help you? Well, if you drive slowly, if you know where you are driving, if you systematically drive day in, day out the same route of, let's say, 3 miles only, maybe you can do this, okay? I tried to do this experiment and I barely made it out of my backyard, all right? So this is not so simple. And really what happened in business we created a whole class of people that knew how to interpret these results and somehow give advice to business. So business was split into 2 parts, like doing the business itself, like, for example, manufacturing products, wrapping them up, then selling them to customers. And then you have people that telling, wait a minute. If we will do a little bit better in our wrapping or in our fulfillment, maybe we can get more sales and so on. So this is how the operational research got into the business, and the split between the doing business and advising on the business or making decisions about where to go with the business became pretty apparent. I'm not telling this is C-level, okay? I'm telling it is a necessary thing that allows, and actually if we will look in history, if you would like to go as far in history as Roman legions marching somewhere in Middle East, probably you will see the same thing, because these are actually commanders that made decisions based on information that have been brought by soldiers. So the soldiers did the job, and the decisions have been made by commanders. So this structure remains in modern business. So all existence of this aggregation and all anything else started to help to make decisions. So the whole slew of systems started to pop up as systems that appearing to help the decision makers to make decisions. So we call them systems of insights. We are looking inside of business. Never mind it is past. So then we started to look, wait a minute, but how to look in the future? How to have this front view uncovered? So discovered that, well, in mechanics it's nice. We have 3 laws of Newton, right? Great thing. In chemistry, we can find, again, pretty much cause-effect law. In other words, we used from yet Victorian England to causal description. We tried to apply it in business, and it didn't work too much, right? What's the cause and effect? You don't know. Why? Because our products are sold somewhere. The consumer has its own specific behavior. So it seems like the business model immediately became by far complex. You know that in our company, we have very few customers. Honestly, it's about 500 customers. Well, it's very big customers like Walmart, like Sam's Club, like these humongous conglomerates. But in general, this is not a problem for us. Our problem is handling the products. The products what we are dealing with are in 10,000s. And this is kind of thing creates problems with supply chain, with scheduling the production, hence building the plans, elementary process. Create a plan for next year has to end up with, roughly speaking, telling, okay, this plant does this plant does that, this plant does that in this amount, right? And here comes the thing that how to predict what is going to be consumed. Because if I'll produce more than my market can absorb, probably I'm doing nothing. On the other hand, if I would like to increase my sales, probably I need to look at another marketing things. And that it led to appearance of the third type of systems of great importance for business is systems of engagement. Whom do we engage in business? It's not our customers, they are ours anyway. We have contractual obligation toward them to deliver that on this schedule. But if we will deliver something that our customers would not be able to sell, we lost. So behavior of the end guy here that buys things from behavior of consumer becomes vitally important. This is why all these systems, like you hear, like Blue Sky, like many others, and like invention of internet was a great thing. Did we do it before? Of course we did it before, but for what money? We assembled a consortium of people that were kind of randomly selected from a consumer, brought them in one place, wine and dined them for a week, tested products on them, whatever else, and then made some very, very skimpy decisions based upon the results of a very small statistical sample. Invention of internet opened up Pandora box because now we can see behavior of human beings. We can see what they think about us. We can see what they think about products. And we can engage them in doing our business through providing us this data.
A question for you, Yigal.
Yes.
Would you employ Romans to do predictive analytics?
No, if I'm at level of Romans, probably I would remain at what we had before, okay? It's kind of great army of experienced salespeople that actually knew their business, yep. Right? It's just, you know, the soldiers knew how to kill. That's what their business. So go,
ready for the modern
go
economy.
Sell, okay? So, and they knew that, for example, if we will add money and we will pay to customer, hey, listen, we will give you, let's say, $5,000, reduce price a little bit. Well, of course, it became kind of the interesting analytical game. Let's see if we will reduce price, what will happen. So the whole pricing game became very important part of this exercise. And for that, we had to have models. This is the difference between Romans and today's business. Okay, Romans had one business. Kill, 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 kill. Okay.
I think every sales leader wants those Romans to be in their sales team. If I can, maybe take some questions here, Yigal. One of the questions was, what are the trends in presenting data insights for visual trends in presenting data insights?
Well, you see, I do not pray to visual God, okay? I think majority of our users, when they see nice pictures, it is easy to perceive, yes. But there must be something that we want to be perceived. And this is actually the predictions, this is actually the results of pretty serious models, because if we are willing to predict a system that does not have the laws like mechanics in Newton, like Maxwell in electricity, things like this, what should we do? We are trying to create empirical laws, right? We are afraid to call them empirical because it sounds like my mother's kitchen. So we call them KPIs. Key performance indicators. Listen to this indicator. Divide this number into this. If this is less than 30, you're doing good. Okay, nice, but I can't create an additive system here, okay? So it's really a very interesting problem. How far should we try to build our empirical model? How many methods in mathematics exist to build empirical things? And of course, statistics proliferates into this like massive things. What the big data gave us opportunity to do is, well, forget this small sampling. The small sampling is, 5 people not determining anything for me. I need to see 50,000 people, 5 million people, and that immediately increased our statistical ensembles to pretty big thing. Then we told, you know what? Actually, if we'll predict some behavior, will always be deviation. So how we will predict? We will first create a model, and then try to tell that everything else is a noise, right? So it reminds me the same story like theoretical physicist was asked to build a fence. So he told, so it's very simple. You first write a dirty word in the air, and then you put wood behind it. So this is approximately the same thing as we're building models. We're telling, we don't know this, we assume, we hypothesize, and then we put at the back this number cruncher, and we'll see, no, it's actually not fit. Maybe we will optimize it so that it will fit. Maybe we'll play with these variables. Maybe we'll try to create a better fit. Tell me that this is science. So it is not. It is kitchen empiric, but it helps a lot.
So Yigal, we're out of time. I'm going to see if there are any questions for the historical lesson here from the audience. I think the journey is certainly one where we are trying to figure out what the data means to us, what application approaches we take to get to a predictive analytic environment, and perhaps even a prescriptive analytic environment. And that's where we are. So unless there are any questions, I think it's time to wrap. So any last-minute questions from the audience? If not, I want to thank you for your time. Yigal, thank you very much.
Thank you very much.
Okay, thank you.
Story with you. Thank you so much.